Hey, good evening, everybody. Hello, hello, hello. If you can hear me, just tap hi or give me your favorite emoji. Tell me that you can hear me right now. I need to know. Hey, Carla. How are you tonight? Dakota, I see you in here too, right? Hey, Dakota. There you are. Well, there we go. Hey, there we go. Alrighty. So, you guys ready to get your apes on here? All right. Okay. So, welcome to tonight's stream, our cast tonight. I'm Josh McNilson, and we're going to be talking a little bit about global energy conservation. Actually, sorry, that's next week. Global energy consumption. I'm going to talk to you a little bit about that tonight. Oh, shoot, it's been almost a month since I actually streamed. A little out of it here. Okay, so let me get my slides up and running. So before I begin, of course, let me tell you thank you for joining me tonight. And of course, if you can, please follow us on all our lovely little social medias. We're on the Twitter, we're on the Instagram, on the YouTubes and all that, at Think5able. We're there. Hopefully you guys are following us. Okay, so let's get into the actual meat of tonight here. Here's my plan. First, I'm going to talk about renewables versus non-renewables. And after that, global energy consumption. All right, so you guys ready for this? See a couple more people showed up. Good evening, everybody who just joined us. All right, so there we go. All right, so I'd like to start off my streams with a little question for you. So please answer this. How is your house or your apartment, your cottage, or your two-bedroom shack, your school, how is it powered? All right, just tap it in there where it says say something nice. Just tell me, how do these structures, how do they get their power? Come on, don't be shy. Just looking for a little bit there. Burning coal, yeah. The power grid, excellent. Electricity, yeah, I'm quite sure some of them could be natural gas there as well. Okay. How about nuclear? Anyone think about nuclear power? Having like a little fusion reactor in your basement? Gosh, I really hope you don't. Okay, so yeah, it's a little too hot. Yeah, the although it keep your swimming pool pretty warm if you have one of those. All right, so let's talk about non-renewable energy sources. Most of what you guys are talking about here are going to be non-renewables. So what exactly is non-renewable? Well, it's something that can't be replaced in our human lifetime. All right, there's a fixed amount of it. We think of them as like our fossil fuels. Coal being one of them, of course, nuclear, natural gas, even petroleum oil. All of those happen to be our non-renewable resources. Okay. Which one do you think we use the most of? Here in the US, which one do you think is the largest provider of energy? Petroleum, okay. Be our gasolines and all. Anyone else want to take a guess? It's a lot more fun when you're active, I promise you. I've cut down on the sugars in my soda, so I'm drinking Coke Zero. I shouldn't be drinking any of it, but slowly wean myself off of it. Alrighty. So if you'll notice, most of these happen to be forms of fossil fuel. Actually, they are not. Yeah, most of them are forms of fossil fuels. And so again, that's why there's a limited amount of these resources. Even the nuclear, there is a limited amount because we can only dig up so much of the uranium or plutonium or whatever we're going to use. Most times it's going to be uranium. So there's only a certain amount of it on the planet. And again, because it's non-renewable, either we cannot either it's not replaceable within a human lifetime, or we're using more than the rate of our consumption is faster than its actual replacement factor. Okay. Alrighty. At any point in time, if you guys have questions, please ask. I just see a question in here. Have you gone over Chapter 5 already with your class? Actually, Bree, yeah. We are just over halfway through Chapter 5 in my class. So we started it at the beginning of January. So that's... I'm a little bit behind. I wanted to be finished with Chapter 5 right now, but I took a couple of days off. One of them, which was to take my son to a video game conference. But, that's neither here nor there. Hashtag greatest dad ever. Anyway, so renewable resources. Again, renewable or replenished naturally, or the consumption is close to that replacement rate, or at least the replacement is greater than our consumption. They can be reused. I have on there renewable versus non-depletable. So I'm going to put a couple of images up on here. They popped up rather quickly. Of those, which ones are renewable and which ones are non-depletable? Remember, I haven't actually told you what the definition of non-depletable is, but let's see what you guys can figure out, right? In my class, I would say just talk amongst yourselves, but a little bit more difficult here online. So which of these up here would you consider to be a non-depletable resource? As in, it's not going away anytime soon. All right, wind popped up as one of the fastest one up there. Solar, excellent. Yeah, we could say tidal would be considered that. So again, what basically we're talking about with non-depletable is that there's such a large source. What is nuclear waste and why can't we use it? Unfortunately, that's not one of the topics I'm going to talk about tonight, but let me finish talking about non-depletable, and then I'll come back to your nuclear waste question. So non-depletable resources are those that there's such an overly large amount that it will basically never go away. Technically, the sun will burn out in 6 billion years, but for us, that won't be a problem. The sun, of course, powers the wind, so therefore we have wind that's going to be non-depletable. And unless for some reason, 3/4 of the planet just goes up as steam and is gone, of course our tidal energy will be non-depletable. Actually, so technically that would also mean our geothermal. You see I love the little picture of Old Faithful down there. I actually got a chance to see it twice in my lifetime so far. I'm very happy about that. So those right there are non-depletable. So technically the only renewable resource I have on here is that log. So the biomass right there is going to be one of the only renewable energy sources we have on here. All right, so let me go back to Dakota's question real quick as to why can't we reuse nuclear waste. So funny thing is, actually, we really can reuse the nuclear waste. We only use a portion of it. It can be recycled and kind of recondensed and used again. I know France does this. If you guys have ever watched, Switched? I'll type it in here. Switched. Switched? Switch. Actually, you can go to switch.org if I'm correct. Let me double check that before I put it in there. Happened to be one of my absolute best. Okay, making the switch. Let's try that one. I have a copy of the movie itself, so I don't really worry about the website. But if you type in "making the switch," they talk about all the different types of energy sources. It's one of my absolute favorite videos to show in my class. It takes me about 2 days to do it, and they go through all the different types of power sources, and they do show that the nuclear power in France, they do kind of recycle it, and the amount of waste that they produce is about the size of a nickel or a quarter right there per X amount of people per year. I don't remember what it is off the top of my head, but the U.S. doesn't, because we still have a large amount of the nuclear fuels that we don't have to recycle it quite yet. So the nuclear waste, again, is going to be stored. It's actually stored on site. And until we need to, we're not going to recycle it. It, of course, will cost money to do so. So you have to look at the benefits that I always talk about in my classes, that APES is like a balancing. For everything you give up, you gain. So you have to figure out where's your balancing point, where's your tipping point. And so as of right now, it costs a little bit to recycle it. And so therefore, we are not going to do so yet. Alrighty, I hope that was helpful for y'all. Let's get back on track. Actually, I do appreciate questions. I try to answer them as much as I possibly can. And so, if you have them, please ask them. I want to be helpful. So, the ultimate source of all power, of course, is the sun. If you were in one of my earlier streams, we're talking about the food webs, food chains. It's the sun. It powers everything. Even those fossil fuels that we looked at earlier are, we always talk in my class, or in my biology classes and my APES classes, when we talk about fossil fuels, everyone says it's from the dinosaurs. It's not actually the dinosaurs. It's way earlier than that. And most of it is actually the decomposed plant materials that create our fossil fuels and such. So it's not the dinosaurs that are doing it. It's their plants. So how do plants grow? Of course, it's from the sun. So again, the ultimate source of all power is still, yet again, the sun. There's only like two things, geothermal and nuclear power, that are derived from nuclear reactions within or on the Earth itself. Even, tidal energy is from the moon's gravitational pull, but, technically the moon wouldn't be there if we didn't have the sun. So it all goes back to the sun is the ultimate source of all power. So my first earlier question was, what powers the your house or your school and all that? If you'd said the sun, even on FRQ, technically they'd have to accept it if you could, go back and explain why you said the sun. And that's always things you need to be looking out for is on FRQs, is making sure that you answer only the question. But if it's an unexpected answer, explain why. Just make sure your explanation is a good one. Man, I'm rolling right through, and this is a really short topic. So please ask me some questions tonight, y'all. I want to try and make this worthwhile. I don't want to waste your time. But if you have questions, I'm here. Energy is one of my favorite units to talk about. So if I don't know it, and if I can't make something up to make it believable, then of course I'll look it up, or I'll even tell you I don't know it. All right. So technically, again, that unit right there was really, really short, or that section of the unit. So here's my next question for you. Who uses the most energy? Very open-ended right here. So I'm expecting lots of different answers depending on who you are. So please type in our little chat window, who uses the most energy? We're down to 4 people. Oh no, that's all right. I hear my dog in the background growling at my other dog. Thank you, Libby. Tertiary consumers. All right, they definitely have to eat more. Dakota's going with China or the U.S. Both of those are legitimate answers. Both people's answers. Okay. Who in your household uses the most energy? Let's go with that one. Being a dad, I control the thermostat. And yet I'm constantly being told to either turn it up or turn it down. Me when I charge my electronics. Your sister, Dakota? Yeah, we see that there's lots of electronics in my house. Being the APES teacher, you'd think I'd be better about this, but we have more TVs than we have people in the house. Each one of us has 2 or 3 electronic devices. Now, I only use one at a time. I'm either on my computer, on my cell phone, or on my Nintendo Switch. Not all of them. However, if you look at my son, a lot more than that. Your grandfather, he'll leave the lights on the TV. Oh, I hate leaving the lights on. And there's no reason to leave the TV on. The only reason why I leave a speaker running is because so my dog can listen to some music and hopefully not chew up my couch anymore. All right, so all those are really good, legitimate answers. But let me show you. You can't fall asleep. Yeah, actually, Dakota, the same way. I fell asleep watching an episode of Doctor Who last night. I have to go back and watch it again. I'm kind of accustomed to doing that now. I even listened to music when I was younger. So let's look at this lovely little chart right here. Not everybody has the same amount of energy. Like I said, all your answers were legitimate and great. I do appreciate that. Not all the nations actually have the same access to the same energy types either. Here in the U.S., we're rather fortunate. We have lots of different energy, lots of different forms, but not everybody is that. That lucky, I guess you can say. You can see I have 2 little lines right there, either side of China. Why would I put those lines right there? What's the purpose of putting those yellow lines on either side of China? By the way, this energy chart was energy usage as of 2016. And I'm going to show you that here in a little bit that the numbers are actually increasing. So why would I put those little yellow lines on either side of China? I'll give it a hint. It is on the Google slide right here. All right, that's a good reason. China is usually an exception when it comes to data. Either they're not giving us the data or something similar to that. The reason why I put it on here is because, yeah, they are changing in their developing state. A portion of China is developing and a portion is developed. So they're kind of in that limbo. They're changing. They're a vast, huge area, but they have pockets of developing and developed. So that's why I kind of put those little divider lines. But so now if you notice everything above China, we call those the developed world, and you can see that they have a vast amount of energy. U.S., of course, is more so than the rest of them. And then below the yellow line, that you can see that it's decreasing rather rapidly down to Bangladesh is 205. Now, a lot of people would argue that, well, the U.S. has a larger population than Bangladesh or Pakistan or whatever. But if you look at India, they outweigh the U.S. in people by far. So look at the title. This is looking at energy use per capita. So they've basically normalized everything. So you can see that the average person in the U.S. is using roughly 7,000. So what energy source does the U.S. rely on? I haven't gotten to that yet. I'll get to that. At least I think I'm getting to that. If not, then I'll go back and talk about it. Which energy source that we're using a lot of. I'm betting you can probably figure it out here in a few minutes. But you can see, again, we're far beyond the amount of energy per person. And like you said, it's because my son's using 3 different electronic devices at the exact same time. We are, we're powering our homes. We, leaving our lights on, sleeping with the TV on. If my wife wasn't the one that turned it off, I'd have to wake up at like 4 a.m. just to turn the TV off. So yeah, we are energy happy. We're constantly using it. And that's because we are a developed nation. We have more access to electronics or cars, even, because this doesn't just show this doesn't tell us what type of energy. So our cars, our houses, eating out, we have to drive there. We have to pay someone to cook the meal, and then we drive back, and then transfer of the waste back and forth. So there's a lot of different reasons why ours is rather high on the scale. and the other countries are not quite. This also goes back into the tragedy comments. We happen to have a lot of it. There's no one really to tell us that we can't. All right, so let me go to my next slide here real quick. Let's talk about the developing nations. Okay, what type of fuel sources are a developing nation going to use? All right, so biomass, yes, excellent. You using your context clues. So a lot of it is going to be biomass. They do have access to commercial energies. Again, that's a type of energy that you'll either going to be purchased to use. Mostly it's going to be coal, natural gas, and oil. Definitely not going to be nuclear. Reason being is a nuclear plant is a little bit more expensive. You have to have a lot more securities around it because of the waste and the actual raw materials they're going to use. But again, also, here's the thing about commercial: it's not always available in all the areas. The government, even our government controls what type of energy we use and where we use it, and even the price of it. Yeah, not necessarily the price, but they do have a hand in that. But other countries control, the price for the fuel, so it could be out of reach for a lot of individuals. So now we come into subsistence energies, kind of like biomass, wood, grass, leaves, even dung. There's plenty of uh, cultures, plenty of villages that actually will cook over top of dung. And believe me, the first time I heard this was like, oh, I ain't having any of that crap. No, thank you. But just put a little pun in there. But actually, it's a viable food source. There's not food source. It's a viable fuel source, especially if you don't have access to the other ones or if it's too expensive for you. You carry, cart around your cows, your donkeys, or even goats, and if you dry out their dung, it can be lit. And most times you're going to do this in open air, so you're not going to smell hardly anything. The winds will carry it off, but it can be used for cooking or at least heating of the home. And you can see that it's just more readily available. And because they're developing nations, they may not have again access to all of the high tech, awesome electronical stuff that we have here. Okay. Any questions so far? Anything I can help you with? Can you think of any countries that you've talked about in your classes so far that would be a developing nation that would use biomass? Carl's got a question right here. What is the con about biomass? So, are there cons? There are some cons, yes. One of the benefits is that, like with wood, trees can regrow rather rapidly. But if you're using the trees faster than what they can be replenished, then that's one of the cons right there. The thought of Easter Island, the big moa heads and all that. It's thought that they chopped down all the trees there for wood, for building the houses, for making of canoes or boats, but it was faster than what could be replenished. The same thing happened with New Zealand. So one of the cons is, yes, biomass is a readily available source, but certain species take a really long time in order to regrow. It can still regrow in your lifetime, but you may have to wait a very long time in order to get it. Another thing is, everything's going to come back to the amount of carbon dioxides too. So biomass, depending on what you're burning, different types of plants can produce different amounts of carbon dioxides. If you accidentally burn like poison ivy, now you're going to set that into the air too. So those are some of the cons I can think of. First off, again, it's the clearing of the entire area or a large portion of the area, and not making it sustainable so that you can use it over time. Okay. So again, go back to my other question. What kind of nations are a developing nation that would use biomass? What's a viable nation for biomass use? Come on, you know some. Argentina. I was thinking somewhere near there. Yes, that's the one I was thinking of was Brazil, the small little tribes out there. Some of the more remote locations within the continent of Africa would work too. It would be great. I know I grew up in a very small town in India. Their power grid is basically it's when I was watching Switch. They're building their power grid, but there are still certain places that don't have it. Look at Puerto Rico right now. They got slammed with that hurricane a couple years ago. Now we have the earthquakes. They're losing power again, so they're having to go back to using biomass. Kenya, exactly. Thank you. I really do like it when you guys participate. Thank you so much. Thank you. You're making me a happy teacher, I promise you. All right, so let's go on to. Hey, I did the clicky thing here. Why are you not doing it? Oh no, my PowerPoint's stopped working. Why are you stopped working? Ah, well, this is funny. So my PowerPoint doesn't want to work. Why not? Let me see what's happening. There we go. I have to manually click on it now. Alrighty, so let's look at this world energy consumption. Okay. You notice that the different colors are in different years. We tried. I found one that has mostly the different decades. Last time it was updated was 2004. So the U.S. going up, a couple of dips, goes back up, and then 2004 went down. One of the FRQ type questions that they would use is, what trends do you see? So either they'll name a country, or if it's just one simple graph, they're going to ask you to name the trends. Okay, so for the U.S., what I would say is at first, and you name the years between 1950 and 1970, you'll see that there's an increase in the amount of energy use. It went down in 1980, back up slightly in 1990 through 2000, and then dropped off again in 2004. Most times they'll just give you a range of years that they want you to look at, but I've been an AP reader for this will be my 5th year now. So these are the kind of things that we're looking for is we know you have knowledge. Can you relay that knowledge to us? And sometimes just talk about a graph. So look at the amount of energy usage in the continent of Africa. Compare that to, say, Australia. So please do. Right now, I want you to compare Africa to Australia's energy use, the overall trends. Right? Just take a moment, just type it in there. You don't have to be shy. Okay. So far, you guys have been doing great. Answer my questions. I thank you for that greatly. I'm down to the last bit of my Coke Zero. See, we're up to 5 people. Yay, 5 people. All right, let me see. Both look like they're experiencing an increase. I agree with that. Our Australia is much larger and faster than Africa's. Definitely agree. So that's a great right there. If this was an FRQ, I would give you definitely points, 2 points, one for saying what's happening. But between them, they're both increasing. And the fact, second point would be that Australia's is much higher than that of Africa's. Excellent. Libby, thank you very much. You can definitely see that I think the reason why Australia is much higher, it's an industrialized nation. It's one of those developed nations, so they have more access to their energy sources. You'll notice that Africa and South America do not. Europe is rather high. When you come to Asia over there, yes, we have some industrialized nations like Saudi Arabia. We have Qatar and all that, or Qatar. But a lot of that space out there is going to be a lot of rural areas. So that's why theirs is still rather low, but it is increasing. Everybody's is increasing. Okay. Is Australia industrialized nation or industrialized nations in general more dependent on fossil fuels? So actually everybody on there is truly dependent on the fossil fuels because it's a very easy source to get. I know it's still underground, you still have to dig it out, but it's still a very large resource and it's rather easy to get. It's rather efficient too, for the most part. Nuclear power is more efficient. If you guys come back next week, I'm going to talk about wind and solar and stuff like that. But everybody's really dependent on fossil fuels. Now, if you're really industrialized nations, the US, many parts of Europe, and I believe even Australia, they also have nuclear power plants. It's because they have the resources to dig it up, refine the nuclear material, and then use those. I don't believe we've actually built a new nuclear power plant since the 1970s, however. But everyone technically is very dependent on fossil fuels, and it's because it is a rather readily usable resource. Now, when you come to wind, relatively easy to capture. The technology is rather easy to create. Solar, now it becomes expensive again, so you're not going to see a lot of solar panels out. People buying solar panels out in the middle of the Amazon rainforest and all that, and it's because of the expense. So everybody's really dependent on the fossil fuels. We're trying to get away from those with our other energy sources, and because the industrialized nations have the money to put into research, you're going to see that they have more options for things that are not fossil fuel use. Let's see if my little clicky thingy is going to work now. Hey, there we go. All right, so you asked earlier, what type of fuel source are we using? So this right here is the world graph. This is basically, you'll notice that all the fossil fuel use in the world versus the new. I keep using the mouse on my screen like y'all can see it. Yeah, I know you can't. Look at the fossil fuel use. Now, if you'll notice that these are in terawatt hours, this is an insanely large measurement. In fact, when we talk about energy usage, we're looking at huge amounts. Terawatts, exawatts, gigawatts, stuff like that. Probably the last time you guys heard the gigawatts was from Back to the Future, and I believe, please tell me you've seen Back to the Future. There are certain movies that people have to watch. Back to the Future is on that list. So yeah, look at fossil fuel use. All three of them. Excellent, Dakota. I appreciate you. Fossil fuel use. 66% of all the world's electricity is because of fossil fuel use. Libby, I appreciate it. That's great. Thank you. It is one of the best. That's not the best movie, not my opinion. I happen to love the Highlander movie. In fact, even my son's named after one of the characters. But fossil fuel use, absolutely massive. I was actually kind of surprised hydro was the next one, but then I remembered about Three Gorges Dam in China, and then we even have our own dams, although we have been dismantling them as of late. And then it goes down to nuclear, and then your renewables are just a tiny little fraction. And you're going to see most of those renewables in your industrialized nations, along with the nuclear. Hydro is easy enough that as long as you have running water, you can use hydro. We are developing newer technology like that. Tidal and underwater, basically we place like turbines under the ocean. That's been fun. I think even Denmark, I'm trying to remember off the top of my head, I think Denmark has been working on that as well. So you asked, here you are. Fossil fuels is the number one producer of electricity in the world. And this is as of 2015, as you see down there. And again, this is all in terawatt hours. So this is, if you ever look at have you guys ever looked at your energy bill? Have your parents ever showed you how much energy you guys are using? If they do, or if you have, you'll notice that your energy use is using kilowatts. So that's 1 times 10 to the third. Yeah, I'm doing math in my head. This is 1 times 10 to the 12th, which is a terawatt. Vast difference, all right? So I got another little pie chart for you. Look right there. This is the amount of energy consumption and who uses the energy in the U.S. So I asked you who uses the most energy. Said there's a variety of answers. Some people said their sister or grandpa. Tertiary consumers, which, yeah, they use a lot because they have to eat a lot. But now look at this right here by the end users: commercial, industrial, transportation, and residential. A lot of it looks very, very close, and you'll notice that this one, we're not using terawatt hours. We're using another term, British Thermal Units, or BTUs. That's one of the terms that mostly is a U.S. term. The rest of the world is going to use the Joule, Joules, not the things that people get in trouble for at your school. The other Joule. But we like to use British Thermal Units because we're different. And notice again, industry is going to use a lot of that power, powering their factories and all that. Transportation. You have to use gasoline to get your car going places. And the commercial, stores, they're the smallest user of energy, which is just that flabbergasted me. I would have thought residential would be smaller, but again, apparently there's going to be more houses than there are, stores and restaurants. So, alrighty. I hate to do this to y'all, but because this is the energy unit, there's one thing we definitely have to talk about, and I kind of hinted at so far. I know in the past, my students have absolutely dreaded this section because they were never allowed to use calculators. But you can now. You can use calculators on the test, all right? So here's the funny thing. There's going to be lots of, yes, I'm sorry, Dakota, math. But think of it this way. Math is a language of science. It's a universal language. So, yeah, I'm sorry. Yeah, I can't help it. But like I said, you get to use calculators. Now, the only problem I have with that, and as APES teachers, we've had discussions, and some of them are nice and some of them are not. We've had discussions back and forth as to the use of calculators. There's one side of the spectrum that says, kids should be able to understand how to do math. Okay. And then the other side of the spectrum is, that's the reason why they have calculators, is to do the math. So College Board has decided, fine, we will allow the use of calculators. You still don't get like a calculations chart, and don't get to have any of the formula chart or anything like that, which is not a problem. Don't worry about it. You don't need the formulas. There's only like 3 or 4 when you truly have to know anyway. But with the use of calculators, they're going to allow us to use actual real world numbers. So you still have to learn how to set it up. You still have to figure out where to put all the numbers. You have to know how to do the calculations. But with the use of the calculators now, we can get actual numbers, real world numbers, and not some fake thing. So yay for calculators, no for decimals. I happen to like decimals. I'm just not a fan of fractions. I tell my freshmen all the time that I feel that fractions were invented to allow math teachers to keep a job. I know that's not true, but I even bought myself a calculator that does fractions. As soon as I graduated high school, that's what I did. My first purchase was to buy me a calculator that can do fractions, because I can't do them in my head. I can do decimals. All right, so let's look at this. Basic energy units we're looking at are the joule. So if you ever see a capital J, that's what the joule is. It is just a unit of energy, just like the meter is a unit of length, okay? Now, you may or may not need to memorize these. The ones I've seen in the multiple choice section, the MCQs, they've given you the conversions over what's a gigajoule, how much is an exajoule, or all stuff like that. So I wouldn't put too much concern into memorizing them, but if you happen to, that would be absolutely wonderful. You definitely have to know how much is a kilo and centis and minor ones like that. Okay, I put quad on here because we use it. Quad is a quadrillion BTUs, but I have never actually seen it in the FRQs or even the multiple choice questions that they've released. So just don't really worry about the quad, okay? If they give you some really oddball, off-the-wall unit, they're more than likely going to give you the conversion for it, okay? But enough of me stalling. Here's a question for you. I am going to work it out, but I'm going to give you guys a moment or two to figure out how you would do it first, okay? So like I said, I am going to work it out. This was actually one of the released exams, one of the multiple choice questions from a released exam, dealing with a coal-powered plant. I kind of paraphrased a little bit, so I think I kept all the numbers the same. So a coal power plant, you're going to produce about 12 million kilowatt hours of electricity per day. What we're trying to figure out is how many BTUs of energy are required to make that electricity, one day's electricity, given the fact that a kilowatt hour is going to need about 10,000 BTUs of heat. That's a whole bunch of numbers, a whole bunch of variables up on the screen. So I don't want to spoil the surprise or anything like that. But if you happen to have pen or paper with you, or even just your phone, whatever you need to do, if you could start figuring out, I am going to show you the setup. I'm going to show you what's expected. I'm going to tell you, I got to grade one of the FRQs last year. I actually graded question number 2, so the math. So I know what they're expecting, where they're going to give you points on here. All right. So I'll give you about 1 minute of deadly little silence to try to start figuring out how you'd set up this program, this problem. Okay. Our little mascot, little baby Groot up here. We'll be waiting patiently for you. He's watching y'all. Okay, but seriously, are any of y'all doing it? Because if not, then I'm just going to continue. Don't need the awkward silence. Hello. All right, so not a problem. Actually, I'm going to tell you right now, Carla, I struggled for a minute, but as soon as I started, it started to fall into place. You know what? It's okay, because the way I'm going to show you, if you don't have a calculator, is perfectly fine there, Libby. Because this was actually one of the questions from, because we haven't had the use of calculators quite yet. So this one was able to be used without the use of calculators. So do you guys know what dimensional analysis is? I know my students, they learned it when they were taking chemistry. They call it something else, but so I totally use dimensional analysis. This is the only way I know how to do most of my math problems, even as an adult, especially when I have lots of different units. So the first thing I do when I'm doing this is I figure out, what is my end unit? What exactly am I looking for? And right there in that last sentence says how many BTUs of energy are required to produce 1 day of electricity. So how many BTUs per day? And so that's, there we go. BTUs per day. That is my end result. That's what I'm looking for. So however I'm setting up my dimensional analysis, I want BTUs on top, days on the bottom. Okay. See, did I do it slowly? I did. So let me start off with that. I happen to know that there is 10,000 BTUs in 1 kilowatt hour. It says that right there in that second sentence. Each kilowatt hour of electricity requires 10,000 BTUs of heat. All right, so that's my first step. Where am I going to go next? I have my BTUs on top. I'm good to go. I don't want to touch the BTU part. So what number am I going to use next on this dimensional analysis? I've got to eventually get to days. So what would I use next? There's a couple of different options. What I like to tell my students is, and I try to teach them this at the beginning of the year, that way they can answer questions. We don't care if you're right or wrong. Nobody's going to laugh at you. If they do laugh at you, they have problems. It's not your problems. If you're accidentally wrong, we will fix it. If you're accidentally right, we'll leave it alone. But we need to trust each other. And the cool thing is, you're just a little tiny icon on the side of the screen. I'm the big fuzzy head. Alrighty. Oh, I don't want to hold you guys up. Yeah, there. Okay. 12 million kilowatt hours of electricity in one day. That's right. We're going to multiply it right there. Look at that. 12 million. That's a whole bunch of zeros. 12 million kilowatt hours per day. I could have put one day or just put the day like I have right there. Thank you, Carla. I know it sounds like I'm just talking and rambling. All right, so we're good right there. Here's what I do. Kilowatt hours is on the bottom and kilowatt hours is on the top. Just cross them out. What are we left with? That's right. BTUs per day. Now just to multiply them through. That hurts. That's a lot of zeros. But the cool thing is, even if you don't have a calculator, if you just remember your rules, you're just going to take 1 times that 12 and just put all those zeros after it. Again, I'm using my cursor on the screen. You can't see it. I feel like a silly boy. So look at that. I have to count. Let's see. That's hundreds, thousands, million. 120 billion BTUs per day. So that's a lot of zeros. There is an easier way, though. Okay. So before I go into the easy way, let me tell you, as a grader, what would happen. 1, you will more than likely get a point for setting it up. Whether you get the answer right or wrong, just setting up the problem with the appropriate units. Right? Setting up the problem correctly with the appropriate units will get you 1 point right there on an FRQ. Getting the answer with the units, and again, you have to have there's to be no naked numbers whatsoever. Okay, having the correct answer right there will get you a point. Now, what happens if you have the correct answer without the setup? Most times they're not going to give you any points. If they don't know how you got the answer, if you just pulled it out of thin air, they're not going to give you the points. Setup gives you a point. Answer gives you a point. Okay, so make sure you do that. It's very important. Even though we're allowed to use calculators now, you still have to show that setup. Okay, that's what we're understanding. College Board still wants to make sure that you can show us how incredibly smart you are. Now, there's a shortcut for this one. A little bit of scientific notation. I prefer the scientific notation, and it's because I may get confused with all those zeros. If you accidentally forget 1 0 or add 1 0, it totally changes the answer. That answer is not going to be wrong. So 10,000 BTUs is 1 times 10 to the 4th. 12 million kilowatt hours is 12 times 10 to the 6th. Or you can even do 1.2 times 10 to the 7th. Either way would work. And since we're multiplying them, just remember some of your math rules. Those exponents will just be added. So that 1 times that 1 in the 12, that's going to be 12. The times 10 to the 4th and the times 10 to the 6th, add those together. That's times 10 to the 10th. And if you'll notice on my answer, there are 10 happy little zeros after that 12 on the top there. All right. Now, another cool thing about the math on the FRQs, if this answer, this 12, was it 100,000? This 120 billion BTUs is to be used in another problem later on. If my dogs are fighting, if your original answer is wrong, they will redo the math using your answer. So it's so we don't have what's called cascading failure. Your wrong answer is now going to make everything else wrong. They don't do that. They will take your wrong answer and then put that into the formula. They want to see that you know what you're talking about. Maybe you had a little mistake. That's perfectly fine. They will take your wrong answer, redo the formulas or whatever for the subsequent questions below. So I really like that. I'm not sure if any other class or any other test does that. I would hope they do. Because, again, College Board is just a test to make sure you understand things, not, if you had little tiny baby mistakes. Okay? Oh, there's my answer. I forgot there. Hey, we're almost come to a close here. Dakota, I hope so too. It makes sense not to have cascading failure. So, again, we're not trying to trick you. We're just trying to see what you know. All right, so like I've only got like 10 minutes left and I've come to the end of my presentation. So is there anything you would like for me to go back and talk about, or is there something that I haven't covered very well that you want a little extra understanding about? I want to make sure your time is worthwhile here. I do appreciate you guys coming tonight. I really do. Not that I wouldn't spend an hour talking to myself, but it's just a lot more fun when there's people in the room. So I will tell you what's coming up next week if you guys are typing in your questions right now. I'm actually streaming again next week, so tell your friends that the big bald guy is streaming next week. Oh, excuse me. I am talking about renewable energy sources, wind, solar, and the conservation of energy. So I'm doing that. I really like the solar and the wind. Those are my favorite ones to talk about. And then conservation of energy, which is different ways that we can, of course, reduce our energy without actually hurting our lifestyle. As of right now, my house is set at 66 degrees Fahrenheit. Hello, dog. 66 degrees Fahrenheit. And you'll notice that most of the people in my house just happen to wear a thicker sweater. In the summertime, and I'm here in Texas, so our temperatures are kind of fun. In summertime, I keep my house at about 78 degrees. Do we need to know about hydraulic fracturing? Actually, yes, I would actually definitely know about that, and it's because it's one of the ways that we can get natural gas is one of the newer ways. We've had differences of opinions in my class about it, and it's a very new and easy way to get. I say new. We've been doing it since like the 50s. Way to get some of the natural gas and other things that are trapped between particles in the ground out. What they'll do is they'll drill a hole down and then sideways and then send little explosions in there to break up the rock, and it'll help to drain the petroleum and the natural gases out. What they also do is, in order to make sure that the particles do not collapse back after the explosions, is they'll pump down a mixture of water, silica, and other lubricants and sand in order to keep those gaps open to help drain. And that's where the problem lies, is that the water can no longer be reused that they pump in there. It can only be used a couple of times, and then it has to be stored. And I live near Oklahoma, and there's lots of earthquakes, which some account because of the hydraulic fracturing that they have in and around Texas and Oklahoma and other states. And the fluids that they use for lubrication have to be kept under pressure, and we can see that it's causing shifts in the land. That's what gives some minor earthquakes. But it gets a lot of the normally unaccessible gas out. So again, everything goes with that balancing act. You have to figure out, where's your tipping point? What state produces the most energy? I would think Texas, because of both the oil and natural gas. We do happen to have a lot of that. I'm not sure if we use more of it or if California. You have to look at the size and social economics and, of course, the population. So even though we have a lot of it, of course, it's being spread throughout the whole U.S. We are producing quite a lot of it. Oklahoma does. We happen to see a lot of the oil derricks there. Texas in the past has been one of the large producers, but I believe, if I'm correct, it's actually Alaska that produces the most of the fossil the fuels. That's the oil and the gas right there. Texas, we're really big on the coal. If you go down by the South Texas, you can see a lot of it there. So I think it's actually Alaska, but don't hold me to that. But I think it's Alaska. Texas being a close second, though. These are great questions, by the way, y'all. Putting me on my spot. Thank you. All right. I didn't even know Texas. Oh yeah, we produce a lot of coal. Your class was learning about the pipes that travel underground, and it's insane. Yeah, actually, my class was talking about what was it? Just last week, it was the Dakota pipeline. But yeah, if you, I used to live down near Houston, and so we have Texas City down there, which is one of the entire city is basically just there to house people who work in uh, the yeah. Sorry, I'm having a brain fart here. The plants down there that are doing the conversions of the raw petroleum into the refineries, all the refineries down there. And so, yeah, not all the pipes are above ground, and it's not all done by trains or anything like that. It's a lot of it is going to be in pipes. And if you were to get a map of the U.S., you could see it's just crisscrossed, a lot of them, but they're going to gather into lots of certain areas, like again Texas City and the South Texas down there. And as for coal, yeah, because it was underwater, it helped to crush down a lot of that coal. So I believe it's a lot of bituminous coal. If you know your different grades of coal, anthracite is the best, bituminous, uh, and then there's lignite, and then there's just peat. So yeah, there's a lot of bituminous down there in South Texas. Alrighty, let's see the next one. How would we know if a pipe is damaged? Excellent question. The pipes themselves are going to have little sensors I want to say, every couple hundred feet or every like 40 feet. And they'll notice like a drop off in pressure or a slowdown in the fuels running through, like the oils. So that's the companies who own those pipes can pinpoint exactly where they need to dig to fix that pipe. It wouldn't be helpful if like you had 100 or even 1,000 mile span of this pipe, and you notice that it's just trickling at the end. So they're going to have little sensors, and even some of them are going to have cameras to show, to make sure that everything's running properly. Because cameras are getting to be really, really cheap nowadays, and so yeah, that's a really good question. Yeah, so we're going to look at little sensors on there, and there's going to be a guy who sits at a computer and looks at data all day long just to make sure that there's no breaks, or if there is, where to send the crews quickly. Because again, once that fuel is starting to leak out into the area, there's massive damage to the surrounding environment. So there's cleanup that's going to cost. You're losing revenue because you can't really reuse that which is trapped in the soil now. Think of Baytown as Exxon Town. Yeah. Used to live near Stinkadena or Pasadena down there too. Yep. Dakota, are you in South Texas or just happen to know about it? You don't have to answer that. You don't have to. Don't worry about it. I want people to think that I'm like, oh, you're in Dallas. Hey, I'm close to you. I'm really close to you. I mean, Wichita Falls. We're famous because we, a couple of summers ago, about 6 years ago, had to recycle our water. It was really neat. Alrighty. Hey, my time has come to an end. I'll take one last question if anybody has them. That way I'm not just blabbering on for the rest of the night. I have dinner waiting for me. So if you don't have any questions, I do appreciate you guys coming here. Thank y'all for coming. Hopefully I was helpful to you, Carla. Thank you for that. Of course, let me end with this. Of course, think of us at Think5able. We're on the Twitter, we're on the Instagram, on the YouTubes. Of course, we have our app too. Hopefully, that's how you guys find out about us. Hopefully, is through the app.5able.me. I'll be here again next week talking about solar and wind and conservation. Okay. So thank you for coming. Tell the people. Hopefully it's a good little preview of your classes to come, or if you've already covered this part, hopefully a good little review. I thank you all for joining me tonight, and I will bid you adieu. Good night, everybody. See you next week.